go to example 1 in section 9.3. This is in your chapter 9 notes packet. Looking at this example, we're given a point, -4, 3. So if I plot that on my XY coordinate, and then I create a right triangle that connects to the origin, I can see here that this point's -4, 3. So my X is 4 units here, and my Y is 3 units up. And the question is asking, evaluate the 6 trig functions of theta. So my theta is going to be the angle here, okay, in my triangle. And I'm going to want to find, this would be, we'll label it R for radius, and we'll talk more about that later, but you can label it any letter you want, and we want to find what that's going to be. So there are 2 ways you could do this. You can just use a squared plus b squared equals c squared, or the equation for R is the square root of x squared plus y squared. And again, this is just a squared plus b squared equals c squared. So I'm going to get the square root of -4 squared plus 3 squared, which is the square root of 16 plus 9, so the square root of 25. And what is R going to equal? Yeah, it should just be 5. So my third side of my triangle is 5. Now I want to find the 6 trig functions, so I'm going to write out all 6 functions. And when I label these, my 4 was negative, so I have to remember that for my adjacent side, this would be A, that 4 is going to be negative. 3 is my opposite, 5 is my hypotenuse. So I can use SOHCAHTOA here. Sine is going to be opposite 3 over hypotenuse over 5. Cosine will be adjacent over hypotenuse. Tangent will be opposite over adjacent. And then flip them all. Cosecant will be 5 over 3. Secant will be -5 over 4. Or you could say 5 over -4. And cotangent will be 4 over 3. Make sure you bring your packet to class tomorrow. We're going to work on more of these problems, and we're going to construct our own unit circle.